myself in a little bit, but before I begin, just want a show of hands. Who here has an organization that is currently in the cloud? Awesome. Hopefully the journey is it's going to be for everyone pretty soon. Now, keep your hands up. Whose organization has an AWS environment or footprint? Awesome. So what I'm going to be talking about is Cloud Metadata Service. I'm going to talk a little bit about what is Instance Metadata Service and across all the platforms, and then going to specifically discuss AWS because of this specific threat actor and how they're able to abuse it. So a quick introduction. I'll do a quick introduction of myself, overview of the metadata service as I mentioned, and why do we care? Like, why are you here? That's what I want to really answer. Why do we care so much, and why it's such a unique thing that I had to put it. After this is done, we put a blog post together, put this talk together, and try to create this as soon as possible. What's the threat landscape like right now? When we're talking about cloud metadata abuse, what does it look like right now across all cloud platforms? And then specifically get into this case study through multiple threat actor, this specific threat actor going against multiple organizations. I'm going to actually do the demo. So what we did was we're able to, through investigation, kind of piece together this puzzle of what exactly the threat actor was able to do. So we put a demo of what they did, and then I'll go through a litany of ways you could detect in your environment, remediate, prevent, and then we'll do that demo again with some of the remediation techniques I talked about and see how even when this was happening, you would be able to prevent it if you were to implement those remediation. Because that's the main thing. I just don't want to tell you your baby's ugly. I want to be able to show everyone how they can fix this. It's something that's very doable. And right here, just a little, this is more housekeeping items where I'm going to be going through a litany of specific cases and all that. I try to obfuscate as much as possible. These are through dozens and hundreds of investigations we've done, and I'm going to obfuscate as much so we don't get it really traced back to a specific incident or not. Quick introduction was a little bit about me. So about 15 years of experience. I have around 5 years of experience working with Mandiant as part of the incident response teams. Really, my main focus and kind of subject matter expertise is around the cloud, but starting from an on-premises background. So on-premises, Active Directory, networking, then going into really cloud when it really started to pick up, especially from the IR side. And leads remediation, so I do, my team is not only on the investigation side, but also containment remediation. So a lot of those containment remediations that I'm going to be talking about are things that we've actively done during an active incident and how we're able to kick out some of the bad guys. And I've seen this happen before on a talk, and I really liked it a lot, where, you know, one thing is, here at Mandiant, at Google, we're hiring. So if you are looking for a job, if you are just thinking about it, add me on LinkedIn, add me on Twitter, shoot me a message. I'm more than happy to really respond and more than happy to talk with you, get your resume, just better understand, because we are always looking for talent. I go across the U.S. and do a lot of talks, and I meet a lot of strong, sharp people, and would love to have, you know, I'm always willing to have a lot of smart people around me, because I never want to be the smartest one in the room, and I never am. So starting off, what is the metadata service? Specifically, we're going to talk about AWS first. And what is Instance Metadata Service within AWS? And you may have heard of this. It's called, you know, for short, IMDS, but Instance Metadata Service. And that is really, it provides critical information. If you're a DevOps person or have any folks in the DevOps, they sometimes utilize this. It provides critical information on the actual virtual machine or EC2 instance if we're talking AWS. It gets you OS information, IP address, subnet, what availability zone it's at. It helps the developers or application understand what's happening on the server at the specific time. And the one thing is, it can only be accessed while in the machine or actually on the machine because it's a link local IP address. It's 169.254.169.254. A simple curl command can get you information. Well, that's only if you have an IMDS version 1. If you have IMDS version 1 and there is a SSRF vulnerability, it will then exacerbate the problem, and this is kind of what we're going to get into with the talk of what exactly this threat actor was able to do. And a simple, as I mentioned, simple curl command can get you all the information, as well as with AWS, you could get IAM credentials because you can attach roles to an EC2 instance to perform an action, which then maybe leads to an S3 bucket or something like that. The key question here, why do we care? Why the hell are you here talking about some obscure instance metadata service, and why do I care? This just came out maybe 6 months ago. Anecdotally, I used to kind of, when I was talking about instance metadata servers before this even threat actor started abusing it, anecdotally, when I saw IRs, when I've done proactive kind of AWS security assessments, I always saw this was, even though this came out, this new version of version 2 came out back in November, December of 2019, this was still something that we saw rampant with a lot of organizations. Well, Datadog, about 6 months ago, put together a great kind of article, and what they went through is 600 plus clients of theirs that have AWS. They were able to see that 93% of all EC2 instances that they manage, 600 plus organizations, had the IMDS version 1. And we're going to talk a little bit about version 1, version 2, and why do we care about version 1 versus version 2. And 95% of organizations had it. So anecdotally, I always had that, and I was always going to kind of mention that, but now that we have that stat that's more scientific than my anecdotes, I always want to bring that up. It's a great thing, and really I can just attest to it just from a personal experience as well. One thing to know, it's not a vulnerability, it's a misconfiguration. So your vulnerability scanners are not going to pick up on this, right? Unless you're using something like an attack surface management, which then is able to pick up more things than just a pure like CVE vulnerability. And it's on by default. As of right now, AWS has not made an announcement that they're going to change it, but it is on by default. So therefore, when you guys in this talk, coming in Monday morning, if you have AWS, you have some EC2 instances, I'm going to give you tips and tricks on exactly what you need to do to detect it if you guys have it, and remediate it. And that's what I really want to give you guys some tidbits when you guys get back on Monday. And this is nothing new, as I mentioned. So if you guys heard, back in the day when it first happened, we did the Capital One. Now it's pretty public. Mandiant and my team, we did the Capital One investigation. This is what the Capital One threat actor utilized, was this IMDS version 1. And this happened in summer of 2019. By November, December, AWS already came out with a response, which was IMDS version 2. So this is not a new thing, but the fact that, as you saw earlier with the stats, it's still so rampant because it's not on by default and not disabled by default version 1, this is still very rampant. One of the things that I mentioned is you can attach a role that can then be leveraged past the EC2 instance, and this is going to be really exacerbated when you have an SSRF attack. So the threat actor utilized an SSRF vulnerability for a specific database management tool called Adminer. This talk is not about the SSRF. It's mainly about this configuration, because one SSRF is there today, another one's there tomorrow. The vulnerabilities for me are not that really pertinent, because if you're able to defend, and we're going to show where even if the application was vulnerable, if you put in these remediations, doesn't matter what if you have a vulnerable application, it will still defend against this. So some of the threat landscape, and the reason why for this talk is, this is the first time, so what we saw was threat actors spraying and praying across an entire AWS CIDR range. We're talking about 2,500 IPs, AWS IPs, where they are saying, we have this SSRF on this Adminer tool, and now we're going to go across the entire AWS CIDR range that they were going for, over 2,500. And as soon as they were able to find a EC2 instance with the misconfiguration that had this Adminer tool, they then, within 3 hours, we saw literally they have created an auto recon tool, and I'm going to talk about that a little bit, to perform the scan. And from there, they came in within 3 hours, and you'll see right away they start going into the EC2 instance, going to S3 buckets, exfiltrating data. They started really quickly. This is the first time, and I myself talked with those in our threat intelligence team within Mandiant, within Google. We talked with, I know a lot of folks in the cloud security community, cloud security, and this is probably the first time we've seen where a threat actor was spraying and praying specifically on a misconfiguration, right? They were really targeting, yes, it was an SSRF, but they were really focusing on this misconfiguration, which was giving them the ability to really wreak havoc. And what we're able to see is with this, we're naming this threat actor UNC 2903. What that means is uncategorized. It's a cluster, threat acting cluster. We don't ascribe it to a nation state, a specific APT group. This is the way when we're doing, when you read a lot of Mandiant reports, you'll see sometimes we'll mention like APT, and APTs kind of came out through Mandiant, right? APT report 1 that came out in 2013 really changed the game of how threat intelligence and how people were performing incident response. But a lot of times, not every major campaign is by a nation state, right? So we put together like clusters, and then maybe after a while we graduate multiple clusters together to then graduate to APT, like we just did recently a couple of months back, APT 43. And what we're able to see is they were also targeting other misconfigurations, which is unique, right? They're not really going after not just vulnerabilities, but other misconfigurations. But really, they were focusing on this Amazon IMDS version 1 abuse. And what were able to see is because, as I mentioned, this is happening at the EC2, it's local. So what happens is, with the SSR vulnerability, it fools the IMDS version 1 into thinking the request is coming from inside the EC2 instance, and you can do it from the outside. What reason for this, why I'm mentioning this, is because this is linked local. This is all happening locally on the EC2 instance. There's not a lot of logging you can do. So piecing together this puzzle of what exactly is transpiring and what exactly they're looking for, it's kind of hard, especially because it's not happening at the management plane level, at the AWS level. It's happening at the local EC2 virtual machine level. And what we also saw is, as I mentioned, is spraying and praying. So this is not going after a targeted industry, targeted set of like, if it's a nation state going after NGOs, they're going after specifically, they have like an objective statement from a mission standpoint. This was spraying and praying, and from there we saw very quickly how they were able to attack. So this is, it really expands all types of industry and verticals. But don't want to only be piling on AWS. So cloud metadata service can be abused across all platforms, maybe not to the extent of how bad you could do with AWS, because a lot of the other cloud providers like Azure and Google has really done some good stuff. So there's actually some great articles from Carl and Marius around how to abuse metadata service using, let's say, like Azure Managed Identities. So there's ways you could still abuse it. Can you do it to the rampant and wreak havoc? You still have to have access to the actual server itself, and you won't be able to go from the outside. And the reason for that is because, one, the metadata, when you're looking through packets, the metadata tag must be true, and also exported for messages, which basically tells tells the virtual machine that this message is coming from outside and is just being forwarded, like a relay or proxy server, is actually coming, it's actually set to reject anything that's coming from the outside. IMDS version 1 does not do that. And I'll actually get into a little bit more on what's happening from the IMDS version 1 versus version 2. With Google, same thing. The metadata flavor has to be set to Google, and also they are automatically blocking and rejecting exported for. So that's one of the reasons why, even though you can abuse it, so like for example in Google, you can abuse it by, if you were to have access to the virtual machine within Google and to the Google machine, you can push, let's say, an SSH key at the project level. So it doesn't matter if any new projects you have SSH keys within that project. So that's something you could do, but it's Andrew Johnson from Matiga put this out maybe about a year ago, where he walked through how you could do that and just abuse the metadata at a Google level. But once again, the baseline things of it coming from the outside world, is kind of blocked because the X44 packets are being blocked, and that's kind of what we're going to get into a little bit. So let me just break down what exactly is happening from this threat actor and this cluster of events. So one thing is, back in February, there was a vulnerability for a database management software called Adminer. And this database management software had the vulnerability was from a long set of specific, like 4.0.0 all the way to 0.17. So it was there for a little bit. And what they're able to do is this vulnerability was disclosed in February, early February. By mid to end February, there was already a POC out there on GitHub for people to, this is where the good guys sometimes, and most likely it was just a good guy doing the research, put his POC out there on GitHub. And we don't have exact concrete proof. So I want to mention this. We don't have exact concrete proof that this is a POC. This is a POC, meaning proof of concept, that this script that the threat actors used was the exact one that we found on GitHub around the same time. But we do have some circumstantial evidence that do point to that, which lends us to then realize that after that was published in February, by June, so about 5 months later, they took that POC script, that Python script, and really put it on steroids. They made it into an auto recon script where they're able to, as I said, spray and pray across a whole host of IP ranges. And then what they were doing is finding that vulnerable adminer machine. Once they were able to do that, we saw them do the manual navigation within 3 hours. They're able to obtain the EC2 secret, access keys and all that, and I'm going to go through a demo of what exactly has happened. Utilize credentials, so once you saw that, able to obtain the secrets, then you saw them come straight in and then start doing the recons, list S3 buckets, auto delete, do some ransomware, a little bit of extortion they can do. They can really do a lot once they're in the S3 bucket. And perform data theft, of course. So now I'm going to go through a demo. What exactly they did, or this is our best educated guess of what exactly has transpired. So what we did was try to mirror the attacker's infrastructure as much as possible. So one is the attacker's hosting a local web server, which then is the one that does a redirection. With the adminer box, that's where it becomes a relay. And it goes in, and specifically hosting the victim address. So it goes and does a request to the vulnerable adminer box. So it's doing the request to the just a local web server, doing a request to the adminer victim. And then it's going to send the request to the attacker's machine because it's thinking because it's doing SSRF vulnerability, it's coming from the inside. This is where it can start querying the metadata service. And you'll see right away how when we run that Python script, you can quickly see the error message that comes out, but even if it's an error message, we don't really care because we are able to get secret access keys, and we're in, and we can just wreak havoc. And then after that, once they're able to obtain the keys, they then take those keys and go straight into the environment. So kind of step one, they host web server and they put a configuration script that goes to this redirect around 169, as I said, 254.169.254, which is internal link local address. It's not exact threat actor used to perform, as I mentioned. I do want to highlight that, but it does do kind of the closest thing that we believe has happened. Next step, you'll see it goes into a admin page. So this is, let's say, the victim's environment, hosted between 4.0 all the way to 4.79. So this is a decent vulnerability version level that's been around for a little bit. And what they'll do is they're going to put it to Elasticsearch. They're going to put in the IP address of the EC2 instance that we're going to see. And simply by putting in the IP address, no username password, so purely the IP address and the port number, you're going to be able to see it's going to be fooled into requesting that it's coming from the actual inside. And we were able to see 302 requests as well as 403. And even though there are error messages at 403, we're able to see full access keys and secret access keys. And we're going to go through, at the bottom, as you see, is the access key ID, the server, a secret access key, as well as a token that is there. And you can make that token as long as you want. That's kind of shorten the lifetime as well. But we're going to go through this entire demo, and then I'm going to go through the detection and mitigations. So this is the demo. I don't trust the demo gods, so we actually recorded it. Make sure that we could go through it, because it's, you never know with internet connections and going in hotels and all that. So I'm going to talk through this though. So going through that, we're going to put in the script, and this script is going to redirect the port 1234 going into the specific IMDS metadata version. So now this is the victim's machine. We're going to put in that IP address that we have and just purely go into, like, let's say Elasticsearch and hit login. And that's all we need right there. We're going to put that and we're going to paste it here. You're going to be able to see literally secret keys, access keys, token expiration, all of that. So literally it's a simple, if you're thinking about how simple it is, they were able to do this, but then do this at a large scale across multiple organizations. And this is, as I said, this is a vulnerable machine because of the version. And this admin, of course, they came out with a patch which blocks the ability because it was something that was happening within the database. But as I mentioned, one SSRF is here today, another one's here tomorrow. I don't want to focus on the SSRF vulnerability for the admin tool too much, because if it's another database administration software, another, let's say, admin software that could do the same things. But what AWS did, they realized this during the Capital One issue, and then they came out with what is IMDS version 2. A lot of great things happened. They made it into a session-oriented protocol. It puts a put request that then requires you to it becomes a token, and then you'll be able to, once you're there, then you can ask a metadata service. It also blocks things from exported for. It's rejected automatically. So this blocks anything that says, hey, I'm just a packet that's coming from the outside world. It's going to automatically block it. It realizes that it needs to come in directly from inside. Also has some new conditions from IAM policies and also SCPs, service control policies, as well as some new CloudWatch metrics. And I'm going to actually walk through all these things that you're able to do that and how you can do that. And also you can put some expirations down to the seconds. So there's some ways you can detect it. I like to always talk about the native ways. Open source tools, I'm never against open source tools, as well as pure command lines. There's also a majority of CSPM tools out there that will detect IMDS version 1. But what I want to have you guys do is, if you have an EC2 instance that is internet facing, that is publicly accessible, prioritize that. Right? If you have a CSPM tool, if you don't have that, you can use the native services like Security Hub, CloudWatch, and config rules to go against your AWS environment. And if you know certain EC2 instances are public facing, go right away and try to mitigate that by going and upgrading to version 2 and disabling version 1. And I'll walk through how to do that, what exact command lines. I will actually we put together a blog, a detailed blog. It's about 10 pages. It's actually a 20-page blog, but 10 pages are just dedicated to detecting, remediating, and we're going to give you the exact command lines. This is not just, you got to figure out the command line. I'm giving you the exact command line to put in to detect, remediate, and also prevent. So I'm giving Terraform policies, CloudFormation templates, basically everything you need to go into your environment and detect and remediate. Some open source tools. So Prowler, which is probably the best tool out there in terms of AWS security. That goes into, if it's a version 1, version 2. Metadata is actually dedicated. It's an open source tool dedicated to just detecting and remediating. It actually does a remediation feature. If you've already done the discussion with your DevOps people and find out, do we really need IMDS version 1? Heck, do we even need IMDS? Do we even need to do the instance metadata service? That's not every organization needs that. Not every DevOps team requires that. And then there's Cloud Mapper made by one of the great AWS security experts, Scott Piper, who put this together, and he has also a check. There's also basic CLI commands, and I put all this specifically in the blog on what to type within your environment and all that. So now detecting the abuse. So detecting the abuse is very hard, as I mentioned, right? Everything's happening locally. But what we're able to see is we saw the admin or software put out a 302 request. And we're like, why? Normally, when you're going purely from an investigation point of view, we're seeing the EC2 instance talk out, which is not typically supposed to happen on this 302 request. That's kind of got our spidey senses tingling, that something's amiss, right? When we're coming into it, the client's not going to tell you, hey, we have IMD as metadata abuse, right? Majority of the time, an organization doesn't have that level of foresight within their environment. And then we saw right after that 302 request, a error 403 request. But as I mentioned, the error message doesn't mean anything because what they got is what they wanted is what they got already, which was that secret key, the access key, and everything. And very quickly we saw from the flow logs the exfiltration of data, as well as if you have data access events. So if you have S3 buckets, one thing we recommend is to have object level logging or data access event logging. There's two types of logging in S3. There's a server access logging and then the data access events or object level logging. If you have a critical server, critical bucket, definitely want to have data access events or object level logging. This will get you the exact how many items within how many objects within the S3 bucket it went through and all that. Then what they did was post Capital One. They also came out, AWS came out with some guard duty alerts. One of them is the EC2 instance used by another AWS account, and then there's another one that says the EC2 instance credentials used by an external IP address. The only issue with this is, even when we did it in our demo environment, this was 15, 20 minutes late. So it had already transpired, the exfiltration, by the time. So as I mentioned, with the cloud, what we've seen is threat actors move it a lot quicker, right? That's the whole reason you're in the cloud is agile, the quick, the compute power, the storage power. And even with our own demo environment, it was very late. We could have already exfiltrated and left before the first alert came through guard duty. So using a larger environment, more production-based environment, that's only going to get a longer time. So this is why we don't want to only focus on the detections. I'm going to really talk about how you can go and remediate and then also preventative measures. So there's ways to remediate, right? There's ways to, like I said, do we even need the IMDS? Do we even need to have the instance metadata service running on that EC2 instance? Majority of the time, probably not. That's where you go talk to your DevOps people and say, hey, are you utilizing this service at all in terms of, does the application require it to query that service to know what IP address it's at, what subnet it's at, what OS information? That's probably not the case. If you do that, just disable it. Forget about IMDS version 1, version 2. If it's needed, then you got to enforce IMDS version 2. And that's where all those great specific remediation techniques come into play because of that enforcement of no X44, session-oriented protocol, and everything. And then you want to detect or remediate all these instances within IMDS version 1. But there's ways to prevent it. And that's kind of where I want to also get into is once you go talk with the DevOps people and realize like, hey, this is going to be a big issue, let's remediate everything that we have, and now let's prevent it from ever happening. So you can create SCPs and IAM policies that any time an EC2 instance is spun up, if it has version 1, it'll fail on the actual spin-up process. It has to have version 2. And within my blog, within the blog that we put together, I have the exact codes you need to put that into SCPs, into IAM policies, where it's requiring the version 2, or HTTP-token is a specific command line thing that it's looking for. We also put together CloudFormation and Terraform templates. If you're using CloudFormation Terraform templates, you can utilize that, copy and paste it, put that straight in. So then you're pushing it at infrastructure as code, where you're preventing this from ever happening, right? You want to remediate, you want to detect, you want to remediate, but also prevent this. Because that's the great thing about the cloud, the security features you can have in the cloud, and that's where when we're talking with a lot of CISOs and CIOs, the preventative features you can have in the cloud, we couldn't do this a lot on-prem. But the defensive mechanisms we have in place, especially from the preventative side, These are things that you couldn't even dream of within the on-prem environment. And so I was also able to do, let's just say you have IMDS, you need it. You can't get to IMDS version 2. Now, just from anecdotally speaking, when I've done these types of remediation exercises, we haven't came across a specific client who could not get to IMDS version 2 because of some sort of technical issues. That's our anecdotal. We've done it through dozens and dozens of clients, but your mileage may vary. But let's just say if you have to use this IMDS version 1 because it's just right now in the remediation plan, we can't have it go to version 2 yet. So there's something called the user data scripts. So user data scripts within EC2 incidents, if you remember, I'm an old Windows administrator days, we used to use the logon scripts. Logon scripts to whenever you log into a Windows machine, it's a logon script that sometimes you map drives, you do some additional kind of scripts to run for some security things. So that's what user data script is essentially, and that's part of the metadata service. What we've seen, and this is outside of just purely from the vulnerability of the SSRF, is ensure that your user data scripts does not have clear text secrets. Because you could use like Scout Suite, which is another open source tool. You can run against your AWS environment. And I've seen literally in some Scout Suite outputs, bash scripts with straight passwords or PowerShell scripts with password equals whatever there. So you want to make sure that you're reviewing these user data scripts if you are using it and ensuring that that is removed. Also, you can limit the number of HTTP put responses. It's right now at from 1 to 60, you could say only one hop. So then if it's going through 2 hops, it'll automatically reject it, just in case, because we're talking about if it's at version 1, it is not blocking and is not rejecting the X44. This is a way to semi-reject the X44, the hops, you're putting it only to 1. You can limit the API calls to version 2 only, and also you can limit the access. So you could say, I only want Bob, the user Bob, to be able to, you could use IP tables, and you say, hey, I only want the user Bob to be able to do 169.254, 169.254. And he's the only one who can query that and curl that command to that specific link local. And you could do that all through command line. And as I mentioned, part of our blog, we will go through this entire thing, exactly what command to use to just limit a specific user to be able to go through that. Now we're going to go through this demo again. And just some magic in the back. And the only thing we've done is put in IMDS version 2. That's the only thing. The same setup is there, you'll see. You'll see everything the same. The only thing we've done in the background is put it to version 2. So this is really hitting the point, which is it's the same vulnerable application, right? There's one SSRF here today, another one tomorrow. Same vulnerable application, but that misconfiguration has now been remediated. So let's say the same threat actor was trying to do something similar to this. This is what's going to happen. So as you can see, we're going to put in the same Python script, same port number. Go up here, Elasticsearch, put in the same IP address going to at 1234, and then just hit that login. And you're going to see unauthorized access right there. So same thing. Same setup, but just that one specific trick of that misconfiguration being removed. Now they're getting unauthorized access. So this is why I wanted to really focus this talk not on the SSRF vulnerability, because that's something that happens a lot, and you can't really predict every vulnerability, right? You can only focus on the things you can really change, which is your own infrastructure and your own services. But doing all that, what we've done is, after this, we put together with Brandon, myself, Tyler, and a few others, put together a blog post. It's very detailed, and if you get a chance to, go review this, like as I saw, a lot of you guys have AWS environments. You probably have EC2 instances. Review that. Make sure your EC2 instances are running version 2. Especially what you want to do is prioritize those that are externally facing. Those that are publicly accessible, those that are outside externally facing, you really want to make sure that you have the version 2, because like I said, an SSRF could come out tomorrow that then makes your specific vulnerability very, very bad. And that's it for today. Any questions? Awesome. Alrighty, I'm giving back some time.